Hey, what's up, dudes? Okay, I got another X-ray today, and he said the X-ray looked good. Gave me a steroid shot in my knee, and I'm gonna get an MRI. I'm gonna go back to work tomorrow, see how I feel. Um, but I'm gonna get an MRI on April 1st, and he might want to do surgery if he sees something in the MRI. I heard the recovery time is pretty fast, which is cool. It's only like a week or two of recovery. So, I mean, I'll probably get it if it's that quick of a recovery, you know. So, anyway, we're picking up where we left off. We're working on, which is cool. It's only like a week. We are working on the mega project, which has been going on forever. Such a massive project, very difficult. Haven't really felt like working on it. It's been like a struggle just to motivate myself to continue working on it, just because it's been going on for so long. And honestly, this part that I'm working on is very difficult. So let's go ahead to our extensions, restart those. Everything looks good here. All right. So last time we fixed our branches, and now we're going to be working from our feature branch, which is called new feature. And this new feature that we're adding is going to be the save system. We already have a basic form of the save system added, but it's not complete. It's really just in its infancy. It hasn't, like, I just basically did some testing to figure out how to use the database and everything, and like figure out the syntax. But as far as actually implementing the system, last time we brainstormed all that. We didn't really add any code, which is really important. Got to do that first. You want to get it right in your head and on paper before you actually write it up in code. Otherwise, you're gonna have a nightmare on your hands of refactoring and just broken code and sadness and pain. So we have 3 different systems that want to interact. They have to be perfectly in sync. One is the actual save mechanism, which is how data gets saved. We thought we were going to do a save thread, but I'm actually second guessing that. I think we might be able to just do something different on a single thread, wherein we just do checkpoint saves. And with a checkpoint save system, we're not going to be persistently saving the data constantly. We're going to we'd be saving at certain checkpoints, and only like saving certain data. Granted, well, yeah, no, like we would save all of the like visuals, card locations and everything, the cards that exist in the hand and the meld and the play cards, pre-sort play cards, everything. That would have to be saved like every time we hit a checkpoint. But there's other data, like, what could we call it? Like, what's the progression logic of the client's game loop. There's certain data structures that would need to be saved specifically associated with each checkpoint. Like, if we had checkpoint 1 in the send section, you know, we're gonna need to save certain data from the send section, but not, you know, data that's from the receive section, because, you know, we're not in that section. We're in the send section. So why would we do that? So yeah, I think I'm fleshing this out in my mind. I don't think we're gonna actually have to use a save thread. I think more reasonably we could just use a function, and I think that we should have some save functions. I think we should have like a function that saves. Let's think about this. How about we have a function that handles saving stuff that needs to be saved regardless of the checkpoint. So regardless of what checkpoint we're at, we still want to save we would want to save I'm thinking about this. When a card gets moved, I was just thinking. So normally we're iterating through basically like 5 or 6 steps, which is send. Well, let's say first off we want to receive data, then we want to apply data, then we would draw the window, which is like redrawing the screen, and then we have filter and then send. So it's like those 5 steps, and in each of those steps let's write this down because this needs to be written down. Well, write this first. Function, we'll say one that saves visual data. We'll just call it visual data, and then one for each checkpoint that saves game progression loop data, i.e. received data, you know, stuff like that. And so we have these basically 5 or so checkpoints. What do you say? Like 4 to 6, whatever. 4 to 6, 4 to 7. We might need a couple more than what we. 4 to 7 checkpoints. Then we have like, so let's say we have receive. Then we have apply. Then we have draw window. Then we have send. And we have like filter. Filter is for like the dictionaries. This is like for the storage dictionaries. Okay. Now when we do draw window, I'm thinking that let's go over to locations and let's pull up draw window. Is draw window main not here? Oh yeah, draw window main is in game. I'm not sure. Let's go this. Okay, here we go. Yeah, there we go. Def draw. Now. Okay, that's not really what I want to see. I want to see where it's called. Because every time we draw the window, like, the cards get moved. So we would need to save the data basically like every time the cards get moved, so that we have you know, like a perfect reference of where a card was, where each card was on the screen at the point of a disconnect. So we have if the length of received data is equal to 4. What is this? What is this? This is in dir check. Okay. This is in dir check as well. So certain functions call draw window main over and over again. This is... Alright, this is what I was looking for. Okay, so in card movement, we call draw window main. And this doesn't have... Like, this is separate from that main 5-step loop I was talking about. Like, we have our main receive, send, filter, apply, draw. But once you hit apply data, that applies certain card movements that were received from the server, and well, that's actually triggered through a card append. But put this instance out. Okay, there we go. So basically, it gets trapped in a while loop. That will take a while, you know, to move the cards and everything. And if we did a save before that and then after that, we would miss out on that card movement data, which is important. We need to save that, like basically like every frame. So what we would need to do is put in a save point, whatever you could call it, a checkpoint, whatever. We want to save that data every time the screen gets redrawn, and that is the equivalent of a draw window main, this function. That is what ends up redrawing the screen, updating it, and blitting it, or whatever you want to call it, onto the screen. So that's what creates a new frame with the new data that had been given. So in this case, we get new card data XY, and then we go ahead and draw that screen to, you know, update the movement, etc. So let's see. I think that would imply that we would just add in this save function from the calling, like inside of draw window main. So basically every time this function got called, at the end of it or at the beginning, I guess we would say, what should we do, at the beginning or at the end? Not sure. I guess we would say it doesn't really matter. I don't know. I guess it probably would matter a little bit, but personally I would say just probably put it at the end. Let's go look at that function just for a second real quick. And okay, so if we were to put it at the beginning, it would precede the event handler. self game state is equal to main. Okay, so there's a lot going on in this function, obviously, as you can see, but I think like updates display to reflect the new game information. Now this makes me wonder, why do I have the event handler called at the beginning instead of at the end? Because if we have like new visual information, wouldn't I want the new visual information to appear first and then to handle input? So we're gonna put a comment about that. I mean, this has been like this for so long, and there's not like bugs apparent associated with it, but it's still something that I would like to know. Is this threaded? How does it work? And then shouldn't it be at the end of the function, since we would want visual update before user input? I mean, that seems to make sense to me, that you would want it at the end. But I'm going to go ahead and say we'll put the save function at the end of, we'll put this save function at the end of this one. And that implies 1725, we'll say save, we'll have a little title for it. We'll call it save system. And we're going to say should probably add in save function, and what we'll call this visual data save function, call here to record visual updates every time. Or persistently. I think that's the term that they use for like constantly. So yeah, and this implies that the draw window call visual data save function at end of draw window main to record updated visual info every frame. Alright, and now we have let's see, implies that this function should be defined in a context in which it can be imported into a game i.e. might need to create this in its own file, which I think we actually did create that file. We called it, save logic. So we do already have a save logic file. So spilled a little bit of this on my keyboard here. Pop another piece of gum. Okay. Yeah, so we'll probably have to add this inside a save logic. Let's open up this file and see what we got going on in there. So on each other checkpoint, we'll call it the game loop data save function. And we can have, let's put this up here. So we have one that saves visual data, and then one for each checkpoint. And we'll call this one the game loop data save function. We'll call the other one the visual data save function. So let's copy this, put this up here. There we go. And the game loop data save function should take an argument, probably the checkpoint ID, which will determine which subset of code will be run. So each subset of code would be associated with each checkpoint / section. Yeah, there we go. So that will allow us to tailor, redirect to the specific, set of data that would need to be saved for each section. This is good. We're getting there. This is a lot more solid. I'm feeling confident about this. Okay. And then apply. We're gonna call game loop blah blah blah. Send blah blah blah, and then filter blah blah blah. Checkpoint operation logic. Where each checkpoint is a main thread. Where each checkpoint and main thread is located. Yeah, so honestly, I don't think we're gonna do the double-threaded save option. Based on what I'm thinking right now, which could always change because I've done this before and like went through different options and flip-flopped back and forth between them over the course of time. That's just how it is. In this case, we would use checkpoint system to periodically save a subset of data using above named functions. And this would reduces code clutter by having it all in a function. And regarding this being inside of a function to reduce code clutter, we would probably want the preliminary save data setup stuff, like where I have all this pragma, journal mode, all that. We probably want that inside of a function as well. Like we just put this inside of a function and probably have it all in this save logic file. Yeah, just to reduce the clutter and all that. So I'm gonna go ahead and put that. We'll say move this into a function, i.e. Save db setup, and move it into save logic pi. Yeah, move it into save logic pi. There we go. So we want to move this function, move it into a function, and we want to move that function into save logic pi, and then we're going to import this. We're going to import that data, that function rather, from that file. So let's take this one step at a time here. I don't want to get scatterbrained. I think we're on track though. This is good. Why is this white now? What did I do? Did I change something? This shouldn't be white. I don't know why. Anyway, that's not a big deal. It's okay. We'll figure that out. So let's go over here to things to do. And I want to be nice and tidy here. Let's make sure this is clean. So far I like all this. Let me put this as a separate issue. We'll say save logic pi. We're gonna say go through this file and refactor it to be the main file for all save logic functions, etc. So step one would be go through file and get rid of old code that is not going to be used. Step two would be to add code from client pi which, get this shit out of the way so I can type, which sets up database. Add code from client pi which sets up database to a function in this file. And then, alright, step 3 is going to be import this function into client pi, and then we're going to call that function. And then we want to create, create the, what do we call this? we'll do the visual first. We'll say visual data save function. Yeah, to handle all visual updates. And then number 6, we're gonna do create the game loop data save function. We can just call this the game data. Well, I would actually prefer this to call this the loop data, because game data can be like include visual data, but visual specifies visual, and then loop specifies like the game loop. So that would be probably a better name, the loop data save function, to handle all game loop logic updates. Function takes checkpoint ID arc to designate which section of code within it to be run would have different sections associated with each checkpoint tailored for that specific use. There we go. Okay, so that's good. Let's go ahead and do that. So let's open up save file first. So we're going to go over here. Let's open up save logic, see what we got in here. Okay, well, it's basically empty. Cool. So for initializing the save thread to contain all related code, put the various code sections into functions which will be imported to and called from client Pi. Put the various code sections into functions, and which will be imported and called from client Pi. Function which has some way to determine which data points have been changed. Function which actually save this change data to save file. Okay. I guess we can put, you know, we can put file purpose. So we'll just put what's the other one? There's red. For some reason this doesn't work for the first line. I don't know why. There's that one, there's this one, and then there's question mark, which makes it blue, but there's another one. Oh, there's to do. Yeah, so if you do to do, it's orange. I guess we'll just make it blue. So yeah, we'll say file purpose. In the file purpose, file created 3/17/25. Purpose to store all save system logic and functions for persistent game state saving to be imported into all pertinent locations, therefore must remain independent for successful imports. Alright, cool. So So that's step one out of the way. We went through the file, got rid of old code. Now we need to add code from client pi, which sets up the database to a function. So let's go over to client, and let's go to the top. It's actually not the very top. What's Control Alt Z, Control Alt N. There we go. Alright, so wanted to get rid of my bookmarks to get that fixed. We don't need to be inside a dir check. We want to start right here, so we're going to put our bookmark right here. Control Alt Z. And now we can quickly just jump to whatever location we want to by using Control Alt N. That's a bookmark extension. It's very useful. Alright, so let's grab this code here, which creates the database. If it doesn't exist, it sets the cursor, executes some setup stuff, logs this, that, and the other. So on and so forth. Okay, so yeah, let's go ahead and replace this code with, we'll call it save db setup. Yeah, there we go. There we go. Have to import save logic pi. Or have to import from save logic pi. But let's go one step at a time here. Well, actually, we'll do that before we forget about it. So we're gonna let's see right here. We'll say from save logic, import save db setup. Now we will copy this code, go over to save logic, and we're going to create def save setup, say save db setup, and it's going to run this code. Nice and simple. So we're going to have to import, let's get a div. And this is going to be Python package, module imports, and we're going to import SQLite 3. Yeah. We're also going to need to import custom logger. So we're going to have a project module imports, and this is going to have import, or we'll say from custom logger import the custom logger. Wait, can't we? Oh yeah, we can't actually import, if it's just a standalone function, we could import it, but if this is a class method, so I don't think you can just import a class method without importing like the class itself. So from custom logger import the custom logger, and that's going to allow us to log. Okay, that's good. I mean, this is the right track. We're on the right track here. So this will create the database file if it doesn't exist. Now, I can't remember if this is proper syntax. Like, since we assigned cursor in this code, wouldn't that mean that cursor execute would work? So if we cd to Canasta, and then let's run the server. There it goes. And then if we do unable to create process. Created this on 340 when I created a new feature branch rename client. Oh, see, there's some weird thing with having a comment on the first line. I don't know why. But if we have a comment on the first line, it doesn't work. I don't know why that is. Strange. So if we put it on line number 2, will that fix it? Yeah. So for whatever reason, having a comment on line 1 messes things up. It's really weird. I don't know why that is. That's why it doesn't syntax properly. I guess this is like a VS Code issue. It's something with VS Code. Always leave line 1 of a file blank if first written line is a comment. Otherwise, it throws error associated with what? Threading? It's some sort of threading thing. Let's go back. Let me see. Let me replicate it. So there it is. It's going to say unable to create process using. The system cannot find the file specified. Let's ask the god ChatGPT about this. There may be an issue with how your Python environment is trying to execute client by a few things to check. Check if the file exists. Run the following in PowerShell. Get child item. Dot client py. If it doesn't appear, it might have been moved or deleted. Check for special characters in the file name. If client py was renamed, there might be hidden characters in the file name. Run with full path instead of py client try. Make sure the first line isn't causing issues. If it starts with something like that. Okay, so this is called a shebang. What is a shebang line? What is up with that? Why does that matter? Okay, hold up. If that's the issue, let's see. If we change it to a regular comment, okay, now it works. So it is. It's because of the shebang line. Whatever this is. What is this? What is this? That was the problem. Please explain. Corrupted shebang line. A shebang, a pound exclamation, at the start of a script tells the system what interpreter to use when executing the file. For example, if this line is correctly formatted or contains invalid characters, Windows or the Python launcher may fail to interpret it correctly, leading to errors like unable to create process. Interesting, interesting. Possible reasons include invalid or missing interpreter path. If the shooting specified an incorrect path on pass, in character summons coupling tips from the source, corrupting coding. Okay. So let's do this. This is something that I actually should do, is use Python from Python default interpreter path. So D, how do I copy this? Let's see. Well, yeah, we just put it on the second line. So let me just put that in notes. Things to remember. Always leave line 1 of file blank if heard written code is a comment using otherwise it will throw it will throw error associated with finding file, as this is also used as a bang indicator for setting the interpreter to be used for that file. To be used for that file, i.e., it will think you are assigning the interpreter. Solution, move to line number 2 and leave line number 1 blank. Okay, so now I know why that is. Okay, where was I? What was I doing exactly? Add code from client which sets up database to this function. Okay, so we did that. So now we import this function into client. We did that. We call the function in client py. We did that. Okay, cool. Let's go back over here and let's put file info. Okay, now let's try to run the code and see if it works. Alright, so it does work. So it's not bugged. Let's go to that bookmark. Okay, so it doesn't throw an error here, so this works. So us creating cursor inside of that function does allow us to execute it, which is pretty cool. It executes that line without throwing an error. Okay, so next we have on our list is to create the visual data save function in this file to handle all visual updates, and then create the loop data save function. So we're gonna copy these two, go back over here, and the loop data is going to take in the checkpoint point ID, arc, There we go. So we have send, receive, apply, draw, and filter currently. That's subject to change. This is just placeholders until we get it more fleshed out. But this is good. So there's the beginning section of loop, or the beginning stage of loop data save function. So let's import these functions into the file. So we're going to import visual data save function and loop data save function. So let's go up here, and then we're going to add that one, and we're also going to add this other one, which is loop data. There we go. So we have visual data save function and loop data save function. Let's go ahead and run it and see what we get. Alright, it works. Just make sure it's running the current version, which it is. Cool. Alright. So what we would do next is we would flesh out this visual data save function. So that's going to be our next step. Put this here. Put finish and finish. This file to handle a game loop logic updates. And this is where we're going to stop. Alright, there we go. So we're in new feature. There we go, it's good. Cool, alright, we made good progress today. We copy that, we're on the right branch, we're going to do git add. We're going to do git commit -m, paste that in. There we go, we got our devlog message, we got our commit made. We did 82 insertions, 17 deletions. We created the save logic temporary file. I think that's what that is. And then recreated that save file because we ran the script. Now we're going to do git push And we're just going to do git push. We don't need to specify because it already knows what the upstream branch is on the remote repository. There we go. So it successfully pushed to remote. Yeah. So we can exit out of this. We'll go over here and create a local backup. So we copy this, go right here, delete this old version, and now we're going to paste in the new one. Let's go to text, devlog all the way to the end. There it is. Alright. Oh yeah, I forgot to rename this to today's date. So there you go. Alright dudes, that was it, and yeah, I'll see you next time. Peace.